All right, so now this is where we actually get the actual models, where we have kind of real world applications going on, and this is something that is seen in a lot of things, anything that's cyclical. You could look at hours of sunlight in a day. You could look at temperature. You could look at like a Ferris wheel. The fair is in town, right? So we could look at that is a sinusoidal function. Anything that is cyclical, you can model with a sinusoidal function, okay? So looking at this example, it says an average adult breathes in now every 4 seconds. That's cyclical, right? We have a maximum when we fill our lungs with air, and then we breathe out. We have a minimum of air in our lungs, right? And then we do it again. All right? So it's cyclical. Okay, so the average minimum amount of air in the lungs is 0.08 liters, and the average maximum is 0.82 liters. Suppose the lungs have a minimum amount of air at t equals 0, and let's go ahead and sketch this function and find an equation. Okay, all right, so to sketch this, it's kind of the same thing that we did before, where I have the minimum and that maximum value. Now, what's the period in this one? What's the period? How long does it take to do one cycle?
4.
I breathe in, that takes, and I breathe out.
8 seconds.
It's actually 4 seconds, because I breathe in, I breathe out, and that's one cycle, and so that takes 4 seconds. Yeah. And so I at first thought it was 8 too, and so that's why I had to ask. So it is 4 seconds. Okay, so the period is 4 seconds, and we're going to pretend that at time 0 we had a minimum. So let's sketch this. We're only looking at the first quadrant. We have a period of 4. I'm going to go ahead and label that middle point of 2. So at time 0, we have a minimum of 0.08. And then we have a maximum of 0.82. So at time 0, we have a minimum amount of air. And then if it takes 4 seconds to complete one cycle, then after 4 seconds, again, have a minimum amount of air in the lungs. So at that peak, at that 2 seconds when I breathe in, you are at the maximum of 0.82. So you got a nice sinusoidal curve. Make sure you connect it in that curvy kind of bell-shaped look. Okay, don't make it look like a parabola. All right. Okay, so what are some things that we need to find? You tell me, what's the first thing you want to find? Amplitude. Okay, so how do I find amplitude? Correct. This is where in number 1 it was really easy to see because I gave you really nice, pretty numbers. This one's not as easy to see. You actually have to calculate it using the 1/2 times the max minus the minimum. Here's where you should have your calculators out. So if you don't already have your calculators out, go ahead and get them out because we're going to definitely use it in part C. So we have 1/2 times the maximum minus the minimum values. Our amplitude is always positive, so that's why I threw the absolute value there. So somebody tell me what the amplitude is of this. 0.37. Okay, then what would be the next natural thing to find once I find amplitude? The midline, or the D. And how do I find the D?
Add the minimum to the...
Correct. Take your minimum value and add the amplitude, or take your maximum value and subtract the amplitude. So you get a midline of 0.45. So if you want to add that in there, you can. It did say to sketch a graph, so we want to keep all our information in there. Okay, so now we found amplitude and midline. What's next? Period. This one's easy to see, right? We have a period of 4. But what does that mean about our equation? Correct. Is what? Right, and it's our b value. I was cryptic there. Yeah. So you take 2 pi over 4 to get your b value of pi over 2. And then finally, my phase shift. Do I have to have a phase shift here? No. If I use what function, then I wouldn't have to use a phase shift.
Cosine.
If I use cosine, and more specifically, negative cosine. So if I use negative cosine, then there is no phase shift. Now, if I used positive cosine, what would I use as my phase shift? 2. Yeah, I would use the maximum. If I wanted to use sine, what would be my phase shift? 1, correct. Yeah, these are all evenly spaced, remember, into quarters. And so where that hits that midline would be at 1. And so if you wanted to use sine, you could use a phase shift of 1. Okay, I like to keep it as simple as possible, so I'm going to use no phase shift and use no negative cosine. All right, so we have now y equals 0.37.
So it's negative cosine if it's at like the.
Oh, it's negative. Sorry.
It's negative cosine if it's at like the minimum.
Correct. If we start at the minimum, it's a negative cosine.
And then max is positive cosine.
Correct. Max would be positive cosine. So since we're starting at the minimum, we're going to do negative 0.37 cosine of pi over 2 x. There is no phase shift, so I just leave it as pi over 2x plus my midline of 0.45. Yes, sir. Okay. Bye. Let me give you your problem set. You should be fine because we're just missing one question. Where are you going? Okay. I'm just going to take your word for it.
I did.
Okay, you did? Okay.
Yeah.
All right, last example, example 5. Okay, so I just mentioned about number of daylight hours, right? So when is without looking at this, just in your experience, when do you have the maximum hours in the day of sunlight?
Summer.
In the summer, right? Yeah, you have really long days. And then, of course, the shortest days would be in the winter, right? It gets dark really early and things like that. Yes?
We're not going to do C on example 4.
Oh, yeah, I totally forgot C. Thank you. Let's go back and do C. I appreciate it. That is an important one to do. Yes, let's go back and do C. Okay, so this is where we use our function to determine the amount of air in the lungs at 5.5 seconds. Now, obviously, I think you all should understand that you're just plugging in 5.5 for x, right? You're just plugging 5.5 for x. However, let's talk about our calculators because this is something we haven't quite done yet. In your calculators, you're taking cosine of something. So that means you're taking cosine of like an angle measure. So remember, there's two different systems of angle measures. There's radians and there's degrees. Now, before when we did word problems, we were in degrees. So what about now? Why?
The pi stuff.
The pi stuff. Yeah, exactly. And so when we found that period, we divided by, when I found that b value, I divided from 2 pi. You could actually have done the same thing in the degree system and gotten a b instead. You just would have had a different b value if you had used what? Degrees. Yeah, I could have found a different b value and I could have done 360 divided by 4. And then that way I would be in the degree mode. Does that make sense? But since I used 2 pi, I'm in radian mode. Yeah, so you could have definitely chosen 360 degrees and done the same model. You just, in your calculator, had to make sure you're in degrees. So this is, yes, so this is where I want to make sure we change to radians. So I like to go to Scratchpad, but you should say rad at the top. If it does not, please follow these directions. So to change to radians, go doc, settings and status, document settings, and go ahead and change your angle to radians and make it your default.
When do we use gradients?
You will not be using gradients.
Like what math?
I've never used gradients.
Do all math classes use gradient or no? Like if you
Once you learn you learn them in pre-cal.
Like if you try to do normal math problems like with this.
Anytime you use cosine or sine, you have to make sure you understand which system you're in. So the fact that I used the 2 pi, you need to now understand that that's going to be in radians.
Let's say you do like a multiplication problem, it won't.
No. Anything that doesn't involve sine or cosine, any of the trig values, it's not going to affect it. Okay? Yes. Now, for stats, okay, so if you're in another class with stats, or if you're like in physics, or if there's a problem that I throw at you that has a degree measure, I just want to show you a quick shortcut that you can always use. If I'm in radians and you don't want to go through the process of making it default to use the degrees, let me just show you really quickly. Like, let's just say I want the sine of 15 degrees. Okay, if I write that in right there, that's actually the sine of 15 radians. right? Because I'm in radians. If I want actually 15 degrees, you actually don't have to go in and change everything to degrees. You can actually go down to this pi button and you have a degree symbol. Okay, and so you can force it to, and that overrides the fact that it's in radians. Okay, so the sine of 15 degrees is that, whereas the sine of 15 radians, just to prove it to you, is different.
So would that be 15 pi automatically?
No, you would have to put in 15 pi.
15 2 pi.
15 radians. So pi radians is 3.14 radians. 2 pi is 6.28 radians. Yeah, it's not automatically, you don't automatically have pi with radians. It's just nice. It's just a nice number that we use. Okay. All right, so you could also do the same thing with radians. You see this little r? So if you're in degree mode and you want to calculate something in radians, you can actually use that little r, kind of like a degree, and it will force it to do radians. So just a little something on your calculator. Okay, so hopefully by now you've plugged in your value. Did anybody get the answer?
Yeah.
What'd you get?
712.
0.712. Yeah, I want to make sure everybody does that to make sure you get 0.712, that you're calculating it correctly. Okay? Yes, sir.
What was the button that you pressed for all the other?
For all of those things, you press the pi button. Yeah, it gives you all the weird stuff. So the imaginary, infinity, E, theta.
0.2 pi. Oh, mine's still in degree.
Yeah, that's why I want you to actually use your calculator, because I want to make sure you get the point, what was it? 712?
Okay, let me change it.
To make it default.
Wait, I don't want to make it.
If you don't want to make it default because you're in stat, then don't do it, and then just make sure you use the little r if you're in radians. Yeah, whichever one you want to do. Or if you're in stat, it depends on which one you use more.
But if we don't use like sine and cosine in there right now, it won't matter. Right?
Yeah, when do you use sine and cosine in stat?
We don't. That's why.
I didn't think so.
Yeah.
Yeah, it's not going to affect you. It's more of a, for my students in calculus, when you're in physics simultaneously. That's more of where you have the problem. Okay, any other questions
Still
on this problem?
degrees?
It's really default.
Correct, yeah, it's kind of frustrating. Okay, so let's look at this last example. So we're talking about hours of sunlight, so that's definitely cyclical. So we don't really need the graph, really. It's just the graph kind of shows you that it's cyclical. What we're really going to pull is the data from the chart. So these are the hours of daylight in Dallas on the first day of each month. Now, this is a little misleading. Typically, if I'm looking at the first day of each month, I typically would have started with 0. They started at 1, but that's okay, just as long as we interpret it correctly. Okay, so anytime we're dealing with time, you can really set times wherever you want it to be, where you want it to start. Typically, when we're talking about months in a year, we typically start with 0, and that's what's like January 1 is called, but they called it month 1 is January 1, which is a little weird, but it's okay. All right, so using the scatter plot, find an equation that models this periodic function. So the same thing that we've been doing before. The first thing I typically find is amplitude. Yeah, so when I find my amplitude, you want to find your minimum and maximum. Correct. Now, since this is data and we know it's not going to be perfect, we like typically month 1 we're going to want to come back to this. You can see it's really close. We have 10.03 and then 10.17, but that's okay. I'm just going to go with whatever my minimum is, which is 10.03. So that's my minimum. What's my maximum? 14.28, right smack in the middle of summer. Okay, so to find my amplitude, we would just take half of the difference between them. Use your calculators. And you should get this number. Yes? Okay. All right, then what's next? Yeah, like the Y, the midline.
Yes.
So that I take my minimum and add the amplitude.
The amplitude is the vertical stretch, right?
Yes.
then.
The amplitude is the vertical stretch. Perfect.
And then the side is the period.
Correct.
Yeah, but isn't the amplitude just the like how come you like half the distance if it's a vertical stretch?
So what's the amplitude of the regular sine and cosine graph? 1. So think of that, I'm stretching by a factor. So it goes from -1 to 1. So then if I stretch it, it's stretching it on both ends. Yeah. Okay. Okay, so we've got our amplitude and midline. Everybody agree with those numbers? All right, so now let's do the period. So obviously we're looking at a year here. So what would be the period if we're talking about months would be 12. If you wanted to, you could change this to days, but they talk about it in months, so I'm going to go with that. All right, so that's my period. So I need to figure out what did I divide by 2 pi by to get that 12. All right, what was the factor? So the b would be 2 pi over 12, which is pi over 6. And again, if you wanted to stay in degrees, you could. You would just do 360 divided by. All right, now, what's the phase shift? Now, I typically, if I had reworked this problem, like I said, I would have probably started with month 0 and then have no phase shift. But since they're telling me month 1, this is a good discussion, since they are telling me, they're dictating the problem that the month starts at 1, that's January 1, then I'm actually going to have a phase shift mathematically, right? Okay, since my low value does start at 1, you can see that on the graph. So we do have a phase shift here of 1, okay? All right, so the phase shift, oh, sorry. This thing likes to jump around. So the phase shift is to the right 1 if we use what function? Negative cosine. Negative cosine. Okay, so let's put all of that together.
And when you use negative cosine, that just means putting like a negative in front of the first thing.
Put a negative in front of the first thing, it means we're starting at a minimum value. Correct. So negative of our amplitude using cosine of pi over 6 times x minus 1 plus 12.155. Good? Okay. All right, now the second question is a little tricky. I've seen, like I said, I've seen problems like this where they talk about number of days instead of months. And so what the next question is asking to find the number of daylight hours for September 15th, which is a certain day in the year. But our model is in terms of months. Okay, so we have to talk about September 15th in number of months. Now, if this was days, you'd have to figure out what day in the year is it, like 200 something, right? Okay, but since we're talking about months, it's a little bit easier. It's the middle of month 9, right? Okay, so we're going to use what? 9.5. Yeah. Since 1 corresponds to the beginning of January, 9 would correspond to the beginning of September. So we would use 9.5. Okay, so it's going to be approximate, right? So then use your calculators and go ahead and calculate what your model at 9.5 would be. And I want to make sure that we get the right answer, that your calculator's in the right mode.
Is this like a predicted value or is it like
It's a predicted value, correct.
But like can these vary at all or not really?
Yeah, obviously they're gonna, so whenever we create models, so the reason why we have math is to be able to model things that are naturally occurring in our world. We're not always gonna get a perfect model every time. And that's what you're learning in statistics, right? You don't get a perfect model every time. You're getting as close as you possibly can. Yeah? Okay. We should have gotten 12.705. Yes? And then always make sure your answer is reasonable. Is that a reasonable answer? Looking over at the chart, if at the beginning of September it's 12.87, at the beginning of October it's 11.88, yes, that makes sense. And also, since we're dealing with word problems, it's good to have our units. I'm not going to make you do complete sentences, but we do need to include units. That would be 12.7 hours. So please make sure and include your units. Okay, any questions? All right, so now I'm going to pass out your problem set.